Question 819. A particle moving along a curve in the plane has a position x of t, y of t at time t is greater than or equal to 0 with dx over dt 4t plus 1 and dy over dt is equal to e to the 1 minus 4t. The particle is at position -1, 2 at time t is equal to 0. What is the slope of the line tangent to the path of the particle at time t is equal to 4? This time, the particle is moving in the plane, right? And we have position vector right here. And the question is, what is the slope of the line tangent to the path of the particle, right? So just like parametric equations, the slope dy over dx is equal to dy over dt over dx over dt, right? dy over dt, it's given right here, e to the 1 minus 4t over dx over dt, that's 4t plus 1, right? So our slope of the tangent line at t is equal to 4 is equal to e to the 1 minus 4 times 4, 4 times 4 plus 1, right? So that's going to be e to the negative 15 over 17, or we can write 1 over 17 e to the 15. That's our slope at t is equal to 4. Question 820. Find the acceleration vector at time t is equal to 4. Okay, this is so easy, right? Here we have a position vector, right? Let's say position is r. So that's x of t, y of t. And then our velocity vector is equal to x prime of t, or dx over dt, and y prime of t, or dy over dt, right? Here we have dx over dt, which is equal to x prime of t. Here we have dy over dt, that's y prime of t, right? Our acceleration vector is equal to, that's derivative of a velocity. So x double prime t, y double prime t, right? Here we have x prime t is equal to 4t plus 1. Then second derivative, x double prime t is just 4. Y prime t is equal to e to the 1 minus 4t. Then y double prime of t is equal to e to the 1 minus 4t times the derivative of this, negative 4, right? So that's going to be equal to negative 4 e to the 1 minus 4t. So our acceleration vector at t is equal to 4 is equal to, then that's going to be 4, comma, if we substitute 4 for t, that's negative 4 e to the 1 minus 16, which is negative 15, right? Or this can be written as 4, comma, negative 4 over e to the power of 15, all right? Question 826. A particle moving along a curve in the plane has a position x of t, y of t at time t is greater than or equal to 0, where x of t is equal to 2t squared minus 4t plus 1, and y of t is not given, but it is known that dy over dt is 4t plus 3. Find the y coordinate at t is equal to 0, given that y over 2 is equal to negative 3. Okay, it is given that dy over dt is 4t plus 3, and the position of y at t is equal to is negative 3, right? So we're going to write definite integral from 0 to 2 dy over dt, right? That is equal to the entire derivative of dy over dt, that's y, right? So using fundamental theorem of calculus, y of 2 minus y of 0. And this position is what we're looking for, right? So definite integral from 0 to 2. dy over dt is 4t plus 3 dt is equal to y of 2 is negative 3 minus y of 0. And if we find the antiderivative of 4t plus 3, that's 2t squared plus 3t from 0 to 2, right? So let's find this value right here. Substitute 2 for t. That's going to be here 2 times 4, 8 plus 6, 14, right? Minus, if we substitute 0 for t, that's going to be 0. So that's minus 3 minus y of 0, right? So our position of y at time t is equal to 0 is negative 3 minus 14, which is equal to negative 17, right? Question 828. A particle moving along a curve in a plane is given by the equations x of t is t squared minus 2 and y of t is 1 minus 3t plus t squared. At what time t is the speed of the particle minimum? Okay, when a particle is moving along a curve in a plane, its speed is given by speed is equal to square root of x prime of t squared plus y prime of t squared, right? Here we have x of t is equal to t squared minus 2. So x prime of t is equal to 2t. Y of t is 1 minus 3t plus t squared. So y prime t is equal to negative 3 plus 2t, right? So our speed is equal to x prime squared, 2t squared plus y prime squared, negative 3 plus 2t squared, right? So if we simplify the expression inside of the radical, that's going to be 4t squared plus 9 minus 12t plus 4t squared. So that's going to be equal to 8t squared minus 12t plus 9. That's our speed, right? The question is to find time t where this speed is minimum, right? And this speed is minimum when the expression inside of the radical is minimum, right? So we're going to let this expression right here is equal to f of t. And what I'm going to do is I'm going to find the time t where this f of t is minimum. All right, so let f of t is equal to 8t squared minus 12t plus 9. In order to find the minimum of f, we're going to have to differentiate this function, right? That's 16t minus 12. And set that is equal to 0. Find the critical point, right? 16t is equal to 12. So we have t is equal to divided by 4, that's 3 over 4, right? So we're gonna test. This is a time. Here's a 0. And f prime is equal to 0 when t is equal to 3 over 4, right? Here's f prime. So if time t is, let's say, 1/2, if this is 1/2, then that's gonna be 16 times 1/2, a minus 12. Negative, right? Did I say that? Okay, what if t is equal to 1? 1 right here. Then 16 minus 12, that's positive, right? So the sign of f prime changes from negative to positive at t is equal to 3 over 4, which means f is decreasing on this interval, increasing on this interval, right? We do have minimum at t is equal to 3 over 4, right? So to conclude, f of t is minimum when t is equal to 3 over 4, and when f of t is minimized, then speed, square root of f of t, that is also minimized, right? So the speed of the particle is minimum when t is equal to 3 over 4, all right? Question 839. A particle moves along a curve y is equal to arc tangent x, so that the x component has a velocity dx over dt is equal to square root 2t squared minus 1 for t is greater than or equal to 0. If the position of the particle is at 2 comma pi over 4 at time t is equal to 1, what is the value of dy over dt at time t is equal to 1? Okay, the question is to find dy over dt at time t is equal to 1, right? Here we have y is equal to arc tangent x, and particle is moving along this curve, right? So we're going to differentiate this equation with respect to time t. Then we'll have dy over dt is equal to the derivative of arctangent is 1 over 1 plus x squared times derivative of x with respect to t, right? That's dx over dt. So far so good. At time t is equal to 1, x is 2 and y is pi over 4, right? And when time t is equal to 1, our dx over dt is square root 2 times 1 squared minus 1, right? So we're going to substitute right here dy over dt when t is equal to 1. It's 1 over 1 plus 2 squared, right? 2 squared times dx over dt, that's a square root 2 times 1 squared minus 1, right? So that's going to be 1 over 5 times square root 2 minus 1, that's 1, right? So that's going to be 1 over 5, right? Question 841. A particle moving along a curve in the plane has a position x, t at time t is from 0 to pi over 2 with x over t is cosine t over 2 minus sine t, and y over t is 2 cosine square t minus 2 cosine t minus 1. How high does the particle reach? Okay, the question how high does the particle reach means they're asking to us find the absolute maximum of the particle in this time interval, right? So we're going to have to differentiate this y with respect to time t and set that is equal to 0, find the critical point, right? So y prime of t is equal to, here, this is actually 2 times cosine t squared, right? Minus 2 cosine t minus 1. So y prime t is 4 cosine t power o times derivative of cosine negative sine, right? Now the derivative of minus 2 cosine t, that's going to be plus 2 sine t, and derivative of negative 1 is equal to 0, right? So let's factor this. We have here 2 and negative sine, right? So I'm going to factor negative 2 sine t, and what we have here is 2 cosine t minus 1, and set that is equal to 0. And y prime is equal to 0 when sine t is equal to 0, or when cosine t is equal to 1/2, right? So sine t is equal to 0 when t is equal to 0. That's it, right? That's it on this interval. And cosine t is equal to 1/2 when t is equal to pi over 3, right? Since the interval is from 0 to pi over 2. This is our endpoint, and this is the only critical point where y prime is equal to 0, right? So let's just find the value of y at the endpoint, y of 0 and y of pi over 2, and find the value of y where y prime is equal to 0, which is equal to y of pi over 3, right? And we're going to have to find the absolute maximum, right? The maximum of these three values, right? Y of 0, here this is our y, this is our y, right? So 2 times cosine 0 square, cosine 0 is 1, right? So that's going to be 2 minus 2 times cosine 0, that's 2 times 1 minus 1. That's 2 minus 2 minus 1. That's minus 1, right? Okay, and y of a pi over 2, that's going to be 2 times cosine square pi over 2 minus 2 times cosine pi over 2 minus 1. Cosine pi over 2 is equal to 0, right? So this is just minus 1, negative 1, right? Okay, y of pi over 3, that's going to be 2 times cosine square pi over 3 minus 2 times cosine pi over 3 minus 1. Okay, cosine pi over 3 is 1/2. So 2 times 1/2 squared, which is equal to 1 over 4, minus 2 times 1/2 minus 1. That's going to be 1/2 minus 1 minus 1. That's negative 3 over 2, negative 1.5, right? So what is our absolute maximum? Negative 1, right? So the question, how high does the particle reach? It reaches up to negative 1. That's our answer. All right?